Good afternoon, geometry students. I hope you're having a good Wednesday. Well, this is Mrs. Strickler here with your second set of lessons for the week. So I want to start with a prayer. Let's start with a prayer. Father in heaven, we just thank you for this day. I pray for all my students that you would help them to understand, to learn well, master all of this material, and stay focused. I pray that all their questions get answered. And I pray for myself that you would strengthen me and help me to be the very best teacher that I can be for them, and you'd bless our time. In Jesus' name, amen. Okay, so let's get started. Today we're going to do lesson 11.2 and 11.3. So I'm going to move out of the picture now, and we will start taking notes on the projector. Okay, so here is the projector. So take out a piece of paper and we're going to start on lesson 11.2. Alright, so this lesson is on the area of trapezoids, rhombuses, and kites. Oh, and by the way, of course, as you know, I'm videotaping at my home, so sometimes we have disruptions from the dishwasher, the dogs, children. Anything can happen when you have all of those things in one place, as you all know from home. So anyway, we might have some disruptions, but we will just keep going in the midst of it. Okay, so let's start with the area of a trapezoid. That formula is 1/2 h b1 plus b2. And our picture looks like this. Now, a trapezoid can have several different shapes, but generally this is how it looks. Just for you to identify the height and the bases. I want to make a quick note at the end. Okay, with that in mind, we're going to do a problem. To make this a little more interesting, I've come up with some pictures. So our first problem has to do with a basketball court. So you can see from this basketball court that there is a trapezoid right near the free throw line. So we're going to figure that out. Here's our problem. The free throw line on an international basketball court is shaped like a trapezoid. Find the area of the free throw lane. All right, now you're going to need to draw a picture of this on your paper, so we'll go back to that. Here's number 1. And we have this picture that looks like this. And our arc comes around here. The basket is down here. And this is 3.8 meters across. I'm sorry, 3.6. And this is 5.8 meters. And this is 6 meters down here. This is our net down here. Okay, so we want to find the area of this whole thing, which was our area in the red part of the picture. Why would we want to know that? Well, look at this. This is a beautiful basketball court. They wanted to have the red outlined. How would you know how much paint to buy if you wanted to just paint these two trapezoids and the middle? Don't want to buy too much, don't want to buy not enough. So we can use math to figure it out. Let's go back here. So we're going to have area equals 1/2. Now the height is 5.8. And each base we're going to combine. Okay, so I have 1/2 of 5.8, and then I have 3.6 plus 6 is 9.6, and adding those two together. And half of 5.8 is 2.9. And when I multiply those together, I end up getting 27.84 meters squared. So that is an example of using our formula for a trapezoid. Okay, so the next formula you need to know is the area of a kite. And that formula is area equals 1/2 d1 times d2. Now d1 and d2 are diameters. So I'm going to draw a picture so that you can help to understand that. Sorry, my phone is just ringing off. Okay. So a kite generally looks like this. Sometimes it's actually a rhombus. A kite can also be a rhombus. That's when they're all the same, like this. But our D's are these diameters that go across. So you can see here that D1 would be this length, and D2 would be this length. So I'm looking at the diameters that go across our shape. Okay, so why don't you go ahead and write those down. And down here, if I had an actual diamond, it would be this one times this one. Okay. Now, I know some of you are interested in music at times, so we're going to look at number 2. And we're going to look at a picture. Here is the edge. Do you see this? This is the edge of the guitar, and this is, I don't know, the handle. I don't know those words. And many times they will have a little, let's see if I can make this bigger. Nope. A little shape in here that is a diamond shape. Do you see those? And that really muddied that up. They're much prettier like that. But you can see generally that that is a diamond shape, a rhombus shape. So our next problem has to do with that. Let's go back to number 2. I'm going to read it out loud. It says rhombus PQRS. So I have a picture like this. P, Q, R, and S. And it looks like this. This is 9, and this is 12, and these are millimeters. Let's see, the diameter here is 9, so it's that one. And PR is the 12, okay? And we want to find the area. Now this shape represents one of the diamonds on our guitar. So we have our guitar that looks like kind of like this, and we have the little diamonds going all the way up that I showed you earlier. So we want to figure that out. So my formula is 1/2 D1 times D2, which is 1/2 D1. Okay, now this is interesting. I didn't tell you this. This 9 represents only this part right here. So my whole diameter would have to be 9 and 9 here. So D1 would be 9 plus 9, which is 18. okay? And then this partial segment here is 12. So D2, this is 12 here, and this is 12 over here. Hope you can see that okay. All right, so D2 would be 12 plus 12. Sorry about that, I didn't see that in the picture. So sometimes they only give us partial diameters, or we have triangles there, and we might have to use the Pythagorean theorem with it. There's a lot of different possibilities. For now, we're going to use the diameter with this problem. So I'm going to put 18 there and 24 there. So I end up with half of 18 is 9, times 24 is 216 millimeters squared. And that is the answer. Okay, I would like you to do some OIOs. Find the area. Number 1. Here's an example of a trapezoid with a different shape. Okay, and here's number 2. That means that is all the way down. And they give us this information down here.
It's probably gonna fall apart when we hold it. Yep.
Hi Johnny. Videotaping, we can hear you. Okay, and here's a different shape rhombus. Alright. This is 30, just that piece. And this is 40 right here. So go ahead and work on those, and you can pause the video right here, and we'll come back in just a few minutes. Alright, I'm going to change colors just because I can. Okay, now number 1. I'm not going to use this length because it's the diagonal. And for a trapezoid, I don't use that. I use just the height and the 2 bases. So the height is the perpendicular distance. That's 4. So I have 1/2 times 4, and then 6 plus 8. So that works out to be 2 times 14, which is 28. All right, now this one is the area of a kite, and I'm going to have 1/2, 6 times 14, which is 3 times 14, and that gives me 42. I want to show all our work, always. Now number 3, okay. Well, we know this is a rhombus. Sorry, that's part of the picture. If this is 30, then this part is 30. And if this is 40, then this part is 40. All right, so I'm going to have D1 equals 30 plus 30, which is 60. And D2 equals 40 plus 40, which is 80. All right. So my area is going to be 1/2 60 times 80. So half of 60 is 30, whoops, times 80 is 2,400 meters squared. And there's your answer and all of your work. Okay. Let's keep going and do a couple more problems. Whoops. Bring it in a little smaller and do number 3. Okay? Number 3 says one diagonal of a kite is twice as long as the other. The area of the kite is 90.25 square inches. All right, what are the length of the diagonals? Okay, that is our question. All right. So let's write down our formula, which is area equals 1/2 d1 times d2. Now I know the area is 90.25, but d1 and d2 are different. So I need to look at what their relationship is to each other. So if I have x equal to 1 diagonal, it says the other one is twice as long as the other. So the other one will be 2x. Okay. So now let's put those in. So I have area is 1/2 times x times 2x. And I'm going to put 90.25 in also. So this becomes x and 2x. Now here, 1/2 and 2 cancel each other out. So I have 90.25 equals just x squared. So how do I get that answer? Well, I take the square root. And if I use the calculator, I find out that the 1 is approximately 9.5. So if d1 is 9.5, what's the other one? Well, the other one is going to be 2 times that. So the other one is going to be 19. And it was in inches. Okay, that's a real kite for you. Okay, number 4, last one. Okay, we have a picture and there's a graph. I'm going to change to graph paper. Okay. Now, let's draw that. I'm going to draw the picture in my notes. The beauty of a videotape is that you can pause it. So if I'm going too fast at any point, you are welcome to pause the video. You can rewind it and listen to it again, or you can just listen to it whenever you want. So you can do your homework and your classwork anytime you want. So that's the beauty of having it on YouTube, because it is videotaped. Okay, so my picture is a It's my dog Rosie. She just barked. Okay, and this goes by tens. So I have tens here, and I'm going up by tens. So 1 point is here. This is E. And then this goes up 1, 2, 3, 4, 5. Right there, is that right? Yes. Okay, that's B. Four, 5, 6, 7, 8. This is D. And this goes over 1, 2, 3, 4. I think this needs to be over one more. No. This is it, 3. 1, 2, 3, 4, 5. Okay. Sorry, few technical difficulties here. So this is C. Okay, sorry about that. This is right here. Okay, so I'm going to draw my shape. And this comes down here. Okay, I'm going to read it out loud. You have a map of a city park. So this trapezoid is our city park. Okay, and each grid represents a 10 meter by 10 meter square. So each one of these represents 10 by 10. That's why we have 10 here and 10 here. Find the area of the park. Okay, so what I need to do is find all my lengths using my grid. So I'm going to change colors. Use some green in honor of the park. So from here down to here, if I measure this length here, that is going to be 40. And if I measure this length here, that's going to be 70. So the whole thing is 70. Now, I don't need my diagonals because that's not part of my formula, but I do need my perpendicular height here. And that would be the difference between these 2 points. So from B down to E, that is 50. 1, 2, 3, 4, 5. Okay, so to find the area then, I use my formula, and I get half of 50 times 40 plus 70. Half of 50 is 25, and I get 110. And when I multiply those, I get 2,750 meters squared. That is the area of the park. All right, that's all we're going to do for lesson 11.2. Here's your homework. I will also put it in the video or in the email. It's pages 733 to 735. 3 through 29 odds, and 35 and 37. Okay, so again, that will also be in the email. So that's all for now. I'll come back in a few minutes with the second lesson, and we will get started.